decimal form, then that decimal will have non-terminating numbers behind the decimal, so they'll keep on going on forever and ever and ever, and they won't be in any particular pattern. So, for example, numbers like, and let's go ahead and write that down. So these are non-terminating decimals. Non-terminating decimals. In other words, the decimals keep on going on and on forever, and no pattern. So not only do the numbers keep on going on and on forever, but they do so in no particular pattern. So some of you might be tempted to say, for example, you might know that the number 1/3, this fraction, has a decimal representation of 0.333, where the 3's keep on going on forever. Alright, so that does fit this part of the description. It says that this number, again, these 3's keep going on forever, therefore it is a non-terminating decimal. However, because these 3's repeat, it does not constitute an irrational number. It's a rational number. We should also know that because, again, it can be represented as a fraction where the bottom number is not 0. Right? Therefore, this is a rational number. Rational. Now, so then what would be an irrational number? Excellent question. Numbers like the square root of 2, put it in your calculator, see what you get. Pi, which is not equal to 3.14. Again, put it in your calculator, see what you get, or look it up online. Numbers like the cubed root of 5. All of these are considered irrational numbers. If you were to put this square root of 2 in your calculator, you'll see that the decimal places never stop, or they give no particular indication that they are repeating in any particular pattern, and you can continue calculating decimal places forever and ever, and they will actually never terminate. Therefore, the square root of 2 is an irrational number. Similarly, pi is an irrational number. The cube root of 5 is an irrational number. All right? If you don't know what the cube root of 5, what that means, we'll talk about that a little more in the next section as well. Now that we know what real numbers are, and there are 4 designations, then let's move on to talk a little bit more about how we represent numbers in an algebra course, or a course that requires college level algebra. Alright. So, before we move on to that, I did want to say one other thing. It's important to note that when we're talking about numbers, just because two numbers, or just because a number has different representations, that does not mean we're talking about two different things. We saw that earlier, again, with 1/3 and 0.33333. All right? So it's very important to make that distinction. The next thing I want to talk about is the real number line. So what is the real number line? The real number line, or real line as it's sometimes called, is a line on which every single point, no matter how small or how close to another point it is, represents some type of real number. It's useful to illustrate this in the form of a line, because in a line maybe you can see that even if I break this little point right here, or you might not be able to see. Let's see. Move it out of there. Maybe you can see it there, or I took my finger and kind of broke the line. That could represent a number. That could perhaps represent the number -3. And if I were to break the line just a simple a millimeter to the left of that, that could represent the number -3.00001. So This representation of the real numbers on the line gives us a little more leeway to actually to talk about real numbers, and also provides a pretty good description so that you can understand what they are, I think. So the real number line, again, is a representation, nothing more, but it can be very useful. In fact, we'll see in the future how we can use it for several things that we'll need to do in this class. Now that we know what real numbers are, and we even have an almost artistic way of representing them, let's talk about the things that we can do with real numbers. So, it's important to note that there are basically two operations that we can do with real numbers. First, what I'm going to talk about is the operations that we can do with rational numbers. Remember, rational numbers are the real numbers that can be represented as a fraction where the denominator, the bottom, is not 0. So, let's say A, B, C, D are real numbers. Real numbers. Okay? Then we can say A over B is a real number, right? Like if A was 1 and B was 2, that would be 1/2. Or if A was 4 and B was 2, this would be 2. All right? A over B plus C over D is how we add fractions, right? Now, how do we add fractions? The basic way is to make sure that both fractions have the same denominator. So anytime we see one fraction plus another fraction, the simplest way to make sure that they both have the same denominator is to take this one, multiply it, take the first fraction, multiply it in the top and the bottom by this denominator, in other words, D over D. Take this one, multiply it in the top and the bottom by this denominator, so that's B, and multiply it by B down here. This little dot in the middle, if you've never seen that before, that tells you to multiply. Then we would find out that this fraction is, in fact, once they both have the same denominator, we can just keep that denominator. So I'm going to write this as DB. Notice that when I don't write a dot in between them, that still indicates multiplication. And then the numerator is DA plus CB. All right? So the moral of the story is, in order to add fractions, they need to have the same denominator. All right? We'll see this come up a lot more in this course. So if you have a problem with fractions, please see me now. This is the time to clear that up so that it won't become an issue in the future. Other thing we can do with fractions is multiply them. So AB times CD, A over B times C over D. Multiplication, straightforward. All you do, multiply the top times the top, bottom times the bottom. So this would be the same thing as AC over BD. Notice that DB is the same thing as D times B. For example, 2 times 3 would be the same thing as 3 times 2, right? Either way, you get 6. All right. Another very important thing to remember about the operations with real numbers. Addition does not respect order. A plus B is the same thing as B plus A. Multiplication does not respect order. A times B is the same thing as B times A. We cannot say the same thing for subtraction and division, though. All right. And in fact, I would like for you to give me an example to show me that A minus B is not the same thing as B minus A. And another example that A divided by B is not the same thing as B divided by A. You should choose values of A and B ahead of time and just work that out on your paper and bring it into class on the next day. The next thing that I want to talk about is the properties of negative numbers. These properties, the next and last thing, actually, I know this thing is getting long. These properties are actually all listed on page 7 of your textbook as Theorem 1. So it's important to note that multiplying a negative number by -1 or making a negative number again negative ultimately changes everything to positive. In other words, if I were to ask you what is -2? Well, -2, according to this thing right here, is just 2. Alright? Hopefully you understand that. If not, you can ask me questions later. Or shoot me an email. And this not only works just for -1 or this just a negative sign by itself. In fact, if I were to multiply -a times b, that would be the same thing as multiplying a times -b, which would also be the same thing as multiplying -1 times a times b. Either way, we get -ab. Alright? So, these are important to know, again, because a lot of times what we'll see is that mathematics, especially algebra, is basically manipulating characters. But we have to be able to follow the rules to be able to manipulate those characters. So if we know all the rules to follow, then the manipulation won't be all that difficult. So for example, if I were to ask you what is -2 times 4, you might easily say -8. Alright? Well, let's see. -8 is the same thing as -2 times 4, right? Because what's 2 times 4 is just, you can't see that. What's 2 times 4? That's just 8, right? So -2 times 4 is the same thing as -8. That would be the same thing as 2 times -4. Either way, we would still get an 8, alright? Excuse me, a -8. It's also important to note that when we multiply two negative values together, -8 times -b, that we get positive. We just get AB. Alright? Excuse me. And finally, dividing a negative by a positive is the same thing as dividing a positive by a negative. Either way, the whole fraction or the whole quotient becomes negative. Alright? And opposite to that, if we take two negatives and divide by one negative by another negative, then that will always equal a positive. Alright? So I think this should be enough for right now. I'm way over my mark. So I plan to make the future videos a lot shorter, and I will probably split this one in two. But I appreciate your time and look forward to working with you in class. See you later. Bye-bye.